Welcome. In this video, I'm going to talk about how we interpret the different parts of expressions given real-world context. So constants don't change, and usually what they'll represent in a real-world problem is a starting value. Operators represent, well, what's happening in the situation. In these expressions, we'll see terms either combined by a plus or a minus. If we see a plus sign, that's going to tell us that whatever the constant is, something's being added to it. The amount is increasing. So plus tells us there's an increase. The same way a minus will tell us there's going to be a decrease. If we had an expression modeling how someone was growing, the operator would be a plus. If the expression is about something like cookies getting eaten, the minus would be the operator because there'd be less cookies as time goes on. So variables represent the quantity that changes, and they represent amounts. To be specific, they represent unknown amounts. They tell us how many of something there are. And then the coefficients, the numbers on the variable, they represent rates of change. With coefficients, we look for words like per or for each. So let's see an example of this. Okay, so Alexandria has been measuring the snow level in inches at a research station in Antarctica. When she started her measurements, there were 15 inches of snow, and it snowed 4.5 inches per week. So she writes the following expression to model this. So let's start with the constant. So looking at the equation, the number by itself is this 15. So the constant is 15. And what does it stand for in terms of the problem? Well, we can see when she started her measurement, there were 15 inches of snow. So that 15 is a starting value. So it's the initial amount of snow. Then we're asked, what is the coefficient and what does it stand for in terms of the problem? So the coefficient is the number in front of the variable. Here we can see it's 4.5. And looking in the description, we can see it snowed 4.5 inches per week. That per is one of the words that tips me off that I have a rate here, which makes it the coefficient. So the coefficient is 4.5, and it stands for the amount it snows each week. Then the variable, so that's our letter. So here's the variable, it's W. And what does it stand for in terms of the problem? Well, variables represent the unknown amount. They tell us how many. So what we don't know here from this situation is how many weeks. So variable represents the amount of weeks. Or we could say how many weeks. Then we want to think about what is the operator in the expression and why did Alexandria choose that operator? So here's our operator. It's a plus. And let's think about what's happening every week. Well, as it snows, the amount of snow level is increasing. So it's a plus because the amount of snow is increasing. Right, one more example. Scroll here. So this is an expression that represents the total cost of apples and pears bought by any customer at Hannaford. I actually want to start with the variables here. We have the A and the P as our two variables. Let's think about what they might represent. We have the total cost of apples and pears. We don't know how many apples or how many pears, so the A, safe to assume A stands for apples, the A represents how many apples were purchased. And then in a similar way, the P must stand for how many pears were purchased. Then we have the question of what does the 0.45 represent? So let's look at it in the expression. The 0.45 is the coefficient on the A, so it must tell us about the rate for apples. And because this expression represents the total cost, the rate is going to be the cost for each apple, or the cost of one apple. You can imagine if we replace the A with a 1, 0.45 times 1 would give us 45 cents, and that would be how much was spent on an apple. In just the same way, that 0.65 must represent the cost of one pear. So there we have some expressions in context where we've interpreted them. Do notice how I've used more than just one word. Try to use phrases like cost of, how many for each. Make sure you answer in complete thoughts. All right, hope this was helpful.